This question is about the elements in period 3 of the periodic table. State the element in period 3 with the largest atomic radius. So remember, they get smaller as you go across a period, which means sodium is going to be the one with the largest atomic radius. Part 2, the highest electronegative value. So this is towards the top right hand corner. So it is going to be chlorine. Part 3, the second highest ionisation energy. That's going to be one that an electron has been removed from a new shell that is closer to the nucleus. So that's going to be sodium as well, because it's second. From magnesium onwards, the second ionisation energy will be in the same shell. But with sodium, we move to a shell that is closer in. And then the highest melting point, that's going to be the macromolecular one, which is silicon here. Okay, part B. Chlorine is a period 3 element. Chlorine forms the molecules CCl4 and CCl2. Use your understanding of electron pair repulsion theory to draw the shape of CCl4 and CCl2. So I'll do it as a full working out. So carbon is in group 4, chlorine is in group 7, but it only brings one electron to the outer shell of carbon, which is the central atom, and there are 4 of them, so that's going to be 4. So the total electrons in the outer shell is going to be 8, divided by 2 is 4 pairs. So 4 pairs that repel equally is going to give you a tetrahedral shape. So here's my chlorines on there. And then the shape of CCl2, so carbon again brings 4 electrons in its outer shell. Chlorine, now we've only got 2 of them this time, and they're going to bring 1 each, so that's going to be 2. So that means that we've got 6 electrons in the outer shell. Divide that by 2, that's going to be 3 pairs. Now with 3 pairs, 2 of them are bonding pairs because I've got 2 chlorines on there, and 1 of them will be a lone pair. So 3 pairs gives me the parent shape. The parent shape of this is going to be trigonal planar. So let me just draw that out first. There's my trigonal planar shape. 2 of them are going to have chlorines on, and 1 of them is going to be a lone pair, like that. Okay. I'm not asked to explain the bond angle or the shape or anything like that, although this one would be 109.25, this one would be 120, take away 2.5, so 117.5, just so that we know. Okay, C, the carbon-chlorine bond is polar. Explain why the carbon-chlorine is a non-polar molecule. Okay, so the tetrahedral shape means that the molecule is symmetrical. And therefore the dipoles cancel out. Okay, so we're not allowed to talk about polar bonds or dipole moments or partial charges. It's about the dipoles that cancel out. Let me just pop this on here. So each of these chlorines is going to be D minus, and then I've got a D plus in the centre. And remember, that's our kind of what we're looking for symmetry. If we've got one of the partial charges in the middle, then we have symmetry. Okay. Okay. D. Suggest with reference to the intermolecular forces present for each compound why CCl4 has a higher boiling point than CCl2. Okay. So let's go through what each of them have. Now it says to the intermolecular forces with an S. That's going to be all of the forces. So CCl4 has van der Waals forces of attraction, between molecules, and that's the only one we're going to have with that one because it is symmetrical. So even though there are polar bonds, the dipoles cancel out, which means it is non-polar. Now with CCl2, if we go back to the diagram here, So I'm going to have D minus, D minus, and then carbon is going to be D plus. So I've got my polarity here. However, it is talking about with reference to the intermolecular forces. So this will also have van der Waals. So let me put a VDW there so I can use that from here on in. So van der Waals force of attraction between molecules, but it also has permanent dipole. Between molecules. So key thing, remember we don't abbreviate until we've written it out once and put that in brackets. Whenever we talk about attraction, we always have to state that it is between whatever is present, and in this case they are both molecules. Okay, so that's the 2 marks, and you need both of those intermolecular forces for that second mark there. That one's relatively straightforward. And then so why CCl4 has a higher boiling point? So basically what we're saying is that the intermolecular forces here are stronger than all of the intermolecular forces that exist between here, because the question is telling you that this one has a higher boiling point, so its intermolecular forces are greater than this one over here. So I'm going to talk about intermolecular forces as a whole, just simple with that one because that's van der Waals, but if I talk about intermolecular forces as a whole, for this one particularly, it umbrellas van der Waals forces of attraction and permanent dipole forces of attraction. Okay, so the intermolecular forces of attraction. So again, just to help me out later, I'm going to do that. In CCl4 are stronger hang on attraction, let's get this right. So the intermolecular forces of attraction between molecules of CCl4 is stronger than the, so I've got my abbreviation in brackets over here so I can use that now, intermolecular forces of attraction between molecules of CCl2. Okay,